I got a request about the best sources for good code. Well, today I'll show you my top 5 sources for code. The first one is here, as you can see it, paperwithcode.com. And it is really nice because you have trending research, and what you have is you have a link to the paper and a link to the GitHub code repository. So you can have a look. There's already some stars. If you are unfamiliar, you can trust other people. You have a short preview what it is all about. And if you're interested in something, this is about trending research. You also have the category new, the latest research, and the greatest, of course. So here, of course, you have TensorFlow and other things you are Transformer, you are familiar with PyTorch and so on, scikit-learn. So this is really a source if you want to learn about whatever you are interested in. Papers with Code is an excellent source because the paper itself, normally, if you look at the PDF, it is an archive paper. And archive is another source I will mention to you in a second. But with Papers with Code, what I find really nice is you have also data sets, you have methods, and you can browse state of the art. So if you are looking for, I don't know, a particular topic, let's say in computer vision, you have here semantic segmentation, image classification, object detection, image generation, denoising, and then you have more than 1,000 tasks. Or if it's not vision, you are in NLP, processing, language modeling, machine translation. You have 1,600 papers with code. So whatever the topic is you're looking for, go for it. The next topic is medical image segmentation. If you have a specific problem with medical images, go here, drug discovery, graph neural network, the latest, 178 papers with code, brain tumor segmentation, medical diagnosis, whatever. If you're interested in methodology, representation learning, really interesting topic, transfer learning, domain adaptation, have a look here. It is really, really a beautiful repository of the paper, a very short abstract, and the code. Abnormally, it's a GitHub code. Well, you might think, okay, should I go in somewhere? Yes, where we jump in? Representation learning. So you have 1,800 papers, you have 4 data sets, and so you go on. And you have a leaderboard, and you have libraries, and you see the point system whatsoever. These are the 4 classical data system for the specific task, word embedding. And then you have a look at the paper. You can look at the paper, and you can look at the code. So if you want to learn really good code, maybe have a look at the original paper. I do it regularly, and I have very positive results with this. The second source, of course, is Kaggle. Kaggle, you have a lot of competitions and whatsoever, but it's nice is there is also new to Kaggle, and they tell you, hey, we have here competitions perfect for newcomers. You have the Titanic, you have the house prices data set, the prediction. Then you have here the active competitions. You can go in, you can have a look, and you can have a look at the Jupyter notebooks of other people. And you can have a look at the notebooks of winner, of people who are really, really advanced in their particular field, in their specific topic. So I would go and recommend have a look at those Jupyter notebooks normally. You have community competitions. Yeah, you can go for prizes. But if you just want to start to learn, I really recommend. Kaggle is really great. And also, if you see here, you have a playground area. You have already a lot of something prepared for you. Have a look, learn from the best. My recommendation. You have the data sets, you have pure code, you have notebooks, you can see what's trending. You can go Python. Yeah, let's go Python, LLP, random forest, whatever. And you see here also numbered whatever filter you set. 4 sources, complete guide. No idea what it is, but you have here the complete code. So if you're looking for something, you have here import, the data, the training set, the missing values, duplicate whatsoever, learn from the best. Of course, if you are highly specialized and you want to really go to the bleeding edge of research, there's nothing better than archive. And archive, I have here now focused on computer science. This is CS abbreviation. And then I just, as you can see here, I put in sentence transformer. And I go for all fields. You can search for the title, you can search for the abstract, you can search whatever you're looking for, newest first, most advanced first, whatever. And then you have here an archive. And if you click at the first one, you see here, this is the short summary. If you're not familiar with archive, and then you have here a download, a PDF download. And here is the original paper. You have here the archive classifier, 7th of April 2022. And you can have a look at the paper and have all the different context whatsoever. What is nice and what is really, really now standard, and unfortunately it's not here, if you have archive and computer science and then you have the particular preprint in archive, you have normally, maybe it is, yeah, you have something like this. Here you have the tool, but here you have the code and data label. So click it open and say official code, no official code found. This is sorry, because here there should be some computer code if you submit to CS. And of course you see here submission and implementation of this paper to paper with code. And this was the first source. So you can see we come back. It's a beautiful ecosystem that is really highly densely interconnected. And there's no limitation for you to learn perfect, great code for the latest of ideas, for the latest of methods, for the latest of algorithms, whatever you're looking for. Source number 4 is conferences. Here ICLR. This is the 10th International Conference on Learning Representation. If you're familiar with Graph Neural Network, you have learning representation, embedding in a lower dimensional topological space, maybe vector space. And you can see here on April 25th to Friday the 29th of 2022, there will be LR 2022. You have here whatever you're interested in, date, calls, guide, organization, profile, and then normally you also have here the speakers. There's an abstract and maybe there's also a link to the presentation at the conference, or there's then a link to a YouTube channel. You find here gorgeous information, presentation by the speaker. Go for those conferences, and of course there's also the machine learning conference coming up. And if this is not enough for you, well, there's Twitter. You can see here my Twitter account, and I have some lists. For example, I have Apache Spark, I have BERT, Transformers, and Sentence BERT. I have here science, knowledge graphs, national science innovation centers, R&D centers, and university on the globe. So let's say we go to the list. BERT and SBERT, come on, here. This is my list. So BERT and SBERT. And you can see bidirectional encode and sentence transformer. This is one of my list. I have 38 members and 47 followers. And if you want, you can copy the list. You can go there. You can have a look at the list. Look at the people I follow. NVIDIA, Hugging Face, Google AI, Stanford, HAI Lab, MIT. Yeah, then specific people. Whatever. Thomas Wolf, of course. DeepMind, Sebastian Ruder, and all the different people, and you have here all their specific links if they have some new papers whatsoever. Twitter is really a gorgeous communication platform. So if you're looking here for other lists from other people, please feel free, go look for sentence transformer, look for graph neural networks, look for topological graph neural networks that are coming up, look for conferences that are here. So I think there's an unlimited amount of resources out there for you. Those are the 5 I would highly recommend if you are interested in improving your code, improving your understanding, improving the understanding of computer science on a theoretical level, especially if you look at probability distribution in graph neural networks, or if you look at, which will be one of my next video, something about a topological graph neural network where we add some topological layers to it. So there's a lot of things to learn. By public demand, these are the 5 sources for you to learn. I would recommend I hope I helped you a little bit in your job, in your learning experience, in your professional career. Thank you, and I see you in the next video.